Well, hi, good morning. Thanks so much for coming and joining me in my shop. Today's the 16th of August, and I'm going to start out with a computer secret that has fooled me for a long time, but not anymore, and I'm going to share it with you. And this is where common sense doesn't fit the facts, basically. So common sense would say if you're having trouble with your computer, like I was this morning when I started up the computer I'm now using to make this video, the computer went wonky in a way I've never actually seen before. And then it eventually just locked right up with a blank screen. I actually never seen this happen before. So in the old days, I'd say, well, I better shut this computer down, because surely to goodness, when you shut it down and start it up, it starts up from scratch and gets all cleaned out and reset and spanking brand new, ready to go. But in fact, that's not what happens with shutdown. That's what happens with restart. Restart, which I thought, well, that's a softer way to kind of reset your computer. Probably doesn't reset everything. Maybe leave some stuff in the RAM or something like that. No. Restart cleans out your computer, makes it all fresh, new, and ready to go. Shutdown, I believe, I may have this wrong, it certainly remembers something. I think it remembers what's in the RAM and reloads the RAM with what was in there last time around. So you don't actually get a fresh start with shutdown. There you go. And I just did it now. I just ran restart and my computer came back fine. It's actually running faster than it was the last couple of days. So there we are. You see, common sense. I remember my father saying to me, Jim, there's no such thing as common sense. And this was always the case with my father. He never explained these statements. He just made these statements. And he did it at dinner, I remember. And I thought to myself, well, what? No such thing as common sense? My dad was right. Okay, what are we going to do today? So yesterday on this radio, I did some signal tracing, and the technique I used was to put a signal into the radio through the antenna, and then use a device to detect the signal at different stages in the radio, see how far into the radio I can go and still detect the signal. And the answer is not very far. Not very far at all. So if I remember right, maybe I don't, I was able to receive the signal at the top of this tube. I'm not so sure now about this one. I can't remember for sure. Was the signal appearing here? I can't remember. So, but it wasn't getting any further than here. Certainly it wasn't coming out the speaker. So today I'm going to do more of that kind of thing, only the other way around. This time I'm going to, instead of send the signal in the antenna and look for it in the radio, I'm going to send the signal into different stages of the radio and listen for it on the speaker. And I'll start as close to the speaker as I think I should, probably the grid cap on the detector tube, and I'm pretty sure we're going to hear the tone come out the speaker. And then I'm going to alter the signal so it matches what should be in the radio and start feeding it in earlier and earlier, moving towards the antenna, and we'll see when things quit working. And then I will have come at it from the front and come at it from the back, and we'll discover the problem is, localized to some place in the radio. Then I can make a better determination as to whether the problem in this radio right now is a really serious problem that I haven't yet identified. If it all relates to the burn coil, which I don't think it all relates to the burn coil, or are the problems just the usual stuff you find in an old radio and it all can be fixed, no problem at all, which I'm guessing is really the state of affairs, except for the coil that's burned. Now that's going to remain a difficult problem. But okay, so probably feeding an audio signal in, and we should really, I could start right at the speaker and work my way back. Well, why not just jump right in the middle and see if by some chance I don't have to work my way back. I can just go back and find that it's there. So the easiest way to do that would be to feed a IF signal, I believe that's 460 kilohertz in this radio, into, I would say, this grid cap. It should go through this tube, go through this transformer, and then reach the detector tube, and then be processed into audio and come out the speaker. And that would prove that everything going this way is fine. And we'd really end up saying the problem is somewhere right in here. let's do that, because that might just sort of cut to the chase, I guess would be the word for it. This is my signal generator here. Okay, I've got it set to 460 kilohertz, which I believe is the IF frequency in this radio. Now, so inside this little box is a capacitor. So there's a capacitor in series with the signal line. So I can go ahead and hook this guy up without too much concern about getting DC back into my venerable signal generator there, which is putting out a moderate signal. Let's see what happens. Okay, we're going to just check a few things, make sure everything's okay. Excuse me, okay. It does appear to be. We have another beautiful weather day today, but it's not going to be sunny. Look out there. Actually, it's partly sunny right now. Rain is coming later. I feel so bad because we've been having just the most fantastic weather here. And I know so many other people in the world are suffering in so many ways with terrible weather. So once again, I'm very lucky. Okay, we hear the radio operating. We don't care what band it's on because all that stuff's kind of in the front end. Once you get to this stage, the radio tunes one frequency only, 460. Here we got it. Okay, sounds like the volume's up fairly high. First, I'm going to touch this to the grid without. That's not a good idea. I'm going to ground this and then touch it to the grid. Okay, we can use this wire here. Volume, please. Make sure I got the right one. That is the volume turned down. Okay. I don't hear anything. Nothing bad is happening. Okay. 460 is supposed to be the frequency of this radio. Maybe it's 455, I got it wrong. 460, 455 won't make any difference for this testing. Or these have been mistuned. They're way off. It's possible they're way off. So the signal's not getting anywhere. I'm going to bump the signal up first. And give it more. Give it more. Give her. Okay, I'm going to double check the calibration here. Right on. There's nothing coming out at all. Is there something I'm doing wrong with the test before I get too involved here? Well, we're still running on low voltage. 86. Let's just go a little higher with it. I'm pretty sure the radio is operating at this voltage. Okay, well, we can go a little higher here. We'll go 10 times higher, not a little higher, 10 times higher. Bingo. Now we're getting something through it. Okay, first thing we're gonna back this down a little bit. Okay, now we're gonna vary this frequency and find out if 460 is really what this radio is looking for. Maybe it's not. .448. So it's off. It's way off. Now it may be tuned. Let's check the volume here. Isn't that nice? It may be that someone has retuned the two transformers to this frequency, and they're both lined up on the one frequency. What's more likely is the radio has drifted off. Someone is fooled with the adjustments in the top here. And each of these, there's 4 actual coils in these two things. And those 4 coils need to be tuned all to the same frequency. So stuff goes through. But they might be all like this. And what happens is any signal has a hard time getting through. There's no clear path through there. It's getting worse. Look at that. It's getting worse. So alignment is adjusting these things to bring them all in alignment and then to place them the right frequency. So they're all together in the right spot. These could be all together in the wrong spot. These could be all over the place. And that's why I need to pump such a strong signal in to get a response. Because it can't get through here. Just can't. These things are not lined up for it to go through. So, how do we know that? Well, what we're going to do now, we're going to turn the volume down first before I get into try. Take this off. So, we want to know now about the strength of the audio side of this radio. Since some sound came out but it was weak, the question might be, is it because of weak audio? So we're going to fire in an audio signal. I'm going to use this generator here to do it. Now this one doesn't have the same capacitor protection here. At least I don't know. So grab a capacitor. Now there really isn't much voltage. I'm going to be touching this to the grid of a tube, grid cap. There's not much voltage there to really worry about in terms of damaging your own equipment, but I think just to be safe, we will use a capacitor here. Okay, the signal output is low. We're at 469 kilohertz. That's very close to where we want to be, actually. That's handy. And we can just shoot down like crazy there. Whoops. Shouldn't have touched that. 450. Oh, no. This is supposed to be an audio frequency, Jim. Get with it, man. Okay, now we're 8 kilohertz. 20 kilohertz. 9 kilohertz. It's a little high, wouldn't you think? Three kilohertz. Okay, that's a nice tone. It's a fairly high tone. Okay, we'll ground this. Now we'll touch it to the grid cap on this tube here. And where's the volume? This is past the volume control, so this is uncontrolled volume-wise. Most radios, this is past the volume control. Not very exciting. So, voila. Something not shielded properly. Every time I bring my hand around here. So we're basically listening to the audio side of this radio now at a fairly high frequency. That's about 1,000 hertz there. Not much I can say about whether this is really good or not really good or anything. The main thing is it's working. It's sending sound through the last stages out to the speaker. I should have. Okay, that's fine. Should have done something else initially. And that's feed this 448 signal into here. I didn't do that. Should get a stronger response. Ground this again. Where'd it go? Where did it go? The volume's turned down. Where'd he go? I turn this down. There we are. That's really terrible, I think. Okay, double checking the tuning here before we do the next. Okay, 443. Now we're gonna just, that signal's going through this tube and through this transformer. Now I'm gonna send it through this tube and this transformer. It should be louder. I should turn this down. Factor of 10. Okay, so that's a similar volume, 1/10 the signal. Well, could it be as simple as the IFs are so far out of whack? This is what's happening here. So I'm going to stop for a few minutes, drink a little coffee. I'm going to look at the alignment instructions, as vague as they are. We're going to try aligning these two transformers and just see if that doesn't just lift the radio rate up from nowhere to somewhere. Okay, first question is, are these things lined up in the wrong place? So we'll make some adjustments on these and see if we can bring up the volume level. I'm going to try it. Get the screw driver. Kind of randomly. We'll start with the second transformer. And we need some sound here. There we are. Make it louder. Not much out of that. Bingo. This last one is just way out. I've aligned this on this frequency, the one it was close to anyway, 443. That's not right. 460 is really where this needs to be. But the radio will work better like this, even. Look at the volume I got out of that. I can't even turn it up all the way anymore. Still low. I am not sending in a regular antenna signal. Since we're right here, let's move this to 460 where it should be. I'm going to stop and just check the documentation before I do it. That 460 is the correct frequency. Okay. This radio has an odd frequency for the IF. 456. Not 455, which is so common. 456. What's a kilohertz? Anyway, so we're going to try to get it there. The way I'm going to do this, again, I'm just going to rely on my hearing and the volume I hear coming out of the radio. Now it's a little hard for you to see. We're at 443 here. A little more volume. So you hear the tone. The tone we're hearing is coming from the signal generator. Now, we're going to move this up towards the frequency that we're shooting for, which is 456, until we can't hear it anymore. We go in the direction we want to go. Just barely hear it. And now I want to turn each of these adjustments and bring it back. I'll start with this one that seems so sensitive. So if you just dial up 456 here, I won't hear anything in the radio, and as I make adjustments, I won't know what's happening. Here we are. anywhere there. You jack up the power here, dial this way up. Almost here at 456. Okay, let's go here. Just going by ear. Where are we now? Okay, I'm going to put this on 456. And we're going to try to do the last pass through there. When I do this at the end of the process, I'll be using an instrument to measure the effectiveness, not just listening. But this is going to get close enough for sure. Shame on me just now. See what I did? Anybody see what I did? Got my hand on the chassis here. You can't see what I did. I grabbed the metal part of this light over here. I try not to do those things. Expose yourself to a shock. Okay, just check this first one again. So this is normally an operation that's done at the last stages of the radio being manufactured. It'll go from the manufacturing line into a test bench area, and somebody will do pretty much what you just saw me do. Well, that's interesting now. The radio should perform better. Is it good enough to actually operate yet? Fat chance. You hear that buzz going on. I mean, that's probably a power supply problem that I haven't deemed important enough to deal with yet. So let's try. Let's see on the antenna. Okay, so we're on the broadcast band. Let's go on shortwave. Shortwave band around 9 megahertz. So we'll dial up 9 megahertz. Let's see what we hear. What do we hear? Let's go here. Not much of anything. Calibration check. Oh, way down. Look, this has to be up. Calibration check again. That's what it was. That guy's down. Okay. We're hitting this with a strong signal at 8.8. The radio's dialed in just above 9. Let's move this, see what happens. Well, nothing. Nothing whatsoever. Okay. Oh, no wonder. I had the volume turned down. It's hard to tell with the buzz. Okay, I got the volume cranked way up. try that again. It's picking up a signal. Can you hear it? The voice? It's picking up a signal, but I was tuning that. It's picking up like a radio station signal. What exactly is going on, I don't know, because all this is producing is a tone. There must be some heterodyning of this with a short wave signal. A little like an image thing going on, or this has become my local oscillator in the radio, and it's mixing with the incoming signal. The incoming signal would have to be 460, 456 away from this. So 8.4. 9.3. Is that right? 9.3 is a very, very strong shortwave signal. I think that's what's happening. We're picking up 9.3. That doesn't quite work, does it? 456 on top of this is only 9.2. Well, no, it's right in there. That's what's happening. We're able to pick up this very strong signal by cheating. Well, if we can pick up that signal on this lead, quick, let's put an antenna on here. I'm going to stop for a minute and get my antennas properly set. Okay, now the very good news about this is proving that at least on short wave, this radio is working. It's just working poorly. And getting it to work better is a lot easier than going from nothing. Okay, so we're going to turn the volume down because it's easy to turn one way, not so easy the other. Get this wire out of here. Okay, antenna ground, antenna wire. This is an outdoor antenna. Not the greatest. Now we're not going to hear 9.3 because we're really not tuned to 9.3. And I'm going to try to tune this radio and pick up that shortwave station.
Thrill out of the fire, on the mountain, the same. Tentacle, farther. Deuteronomy 32.
Don't. Oh, we'll muffle it. Excellent. Now we'll do the same thing on broadcast and get fingers crossed. If the broadcast band works too, then that burn coil is still working. But the burn coil clearly is not affecting the shortwave, although it's very, very weak. Okay, this is good. This is very good. So we'll go to the other band. We're on the antenna. We'll try picking up some stuff. Even just noises and stuff. Well, I can hear it. Is that the short and the tuning thing? We'll go back to short wave. Same crunching. So probably some dirt in the capacitor there. Not necessarily. Not exactly picking anything up, are we? Except for the scratchy noise. No, if we're not picking anything up down here, we're not going to pick up anything anywhere. Let's put the signal generator to it. I'll dial this up to my favorite, 1 million. Hey, there's some noise. Oh, that's a thumbs up. But that signal we're listening to could be getting into the radio, not just from the antenna, but just from here in my shop. Just from being here. Yeah, I think that's what's happening there. Seems like the front end of this radio is really, really weak. Probably due to bad capacitors. Okay, so we're dialed up on 10. We're going to switch off from the antenna. We're going to switch back to the signal generator here. And we want to feed in 1 million hertz. 1 million. Come on. Come on. Oh, oh, oh. Oh, oh, oh. It sounds like somebody from another planet, but I think that's at least one thumb up on that. So some amount of signal. It's not particularly, it's not super strong coming from the. That's good. Turn the radio off. Excellent. Yeah, goodbye to that hum. Fantastic. Okay, so we've ended today basically discovering that the radio is largely working. One of the signal blocks in it was simply mistuned IF. Probably the signal is weakened all over the place by the tired old capacitors that are in here. But at this point, we know something. We know something finally. And I'm going to test this battery, which has been sitting here for a day or two. Has it got any juice left in it? Perhaps even these things could be faulted for weakening the output of the radio. How many volts you got left in you? What's the pressure, Kenneth? Big fat zero. Oh, wait a minute. No, that was my finger. Wait a minute. No. Hold on. It's just really hard to know you're making a contact here. Get my fingers involved and there can be electrolytic action on the metals because I'm touching them. Well, that looks like a that looks like a zero to me. Oh, what's up? Yeah, I just brushed up against it here. I think they're dead. I mean, that's what I would expect. Power's off. I'll put it in. But the signal will pass right through the battery. The signal of the radio will pass through the battery, reach the tube, and carry on in the radio. The batteries being dead may be the you get incorrect bias on some of the tubes, and perhaps the amplification goes down on those tubes, and you get a weak output because of it. So next step, now I'm much more comfortable working on this radio now. Up until now I have not been comfortable. I think what we should try to get rid of that hum sound. So we'll go after the power supply, which probably amounts to augmenting the power supply filter capacitors. The one's here. There was another one. The other one's up here. We have to look in the circuit diagram, figure out what these two capacitors are actually doing, how they work in the circuit, what's going on. I think it's probably just a pi filter with the field coil in the middle. But until I look, I can't really know. Well, that's great. I feel great. That's good. Good news for the owners of this radio who are quite interested in seeing it work again. They're quite attached to it, of course. Had this for years and years and years. And okay, great. Well, thanks a lot for watching, and I'm going to go outside now, play with my cats, enjoy the good weather, start doing yard work. See ya.